Big changes are coming. Do you know that the Earth right now has changed as recently as less than the last 2 years? Our planet is changing and we're on it. And we need to be aware of these changes. Recent headlines, as you can see, Earth's rotation is mysteriously slowing down. Experts predict uptick in 2018 earthquakes. Headlines are now coming up because it has now been released to the world population that our planet is slowing down. Already we can't really keep a track on time. Our planet, we like to think, rotates at a steady rate and, the deviations from that are minimal. But it's not that way. It's why we have to adjust each 4 years for a leap year. If our planet determines our perception of time, then time is truly changing. Now, I want you to stop and think about it. According to the headlines and the scientists, and we would only have known this because of the instruments that we now had. If we didn't have these instruments, we wouldn't know. And so you have to begin to open to the thought that maybe this has happened more often than we are aware of. But let's deal with the here and now, right now. The Earth rotates at approximately 1,060 miles an hour. That's how fast we're spinning. Now, when you take the fact that you have the atmosphere, you have the water, you have land, that, folks, is a lot of mass. And as it would be for let's say, a very large freight train, you tap on the brakes even the slightest, and it sends reverberations through the whole train itself, much as to what has happened to our Earth. The Earth is slowing down. The Earth is spinning slower than what it was when the international second was defined using atomic clocks. So we're losing time on those clocks. We're losing time. In fact, you could say this, and you would be above the ridicule. Time has slowed down for our planet. Now, when you take the fact that the Earth is not exactly level, in other words, it doesn't point due north, due south, it has a tilt. Well, so does our solar system, so does our galaxy. So as the Earth spins, we know that we get the seasons, and it's a normal type of drift of about 23.4 degrees. Recently, that is now beginning to be extended to nearly 26 degrees. There's a transference of energy on a scale most of us have no idea, but we're going to get a really good lesson in inertia. Because you see, our planet, as I said, seems to be expanding and retracting over the millions and billions of years that our planet has been here. We're just now beginning to figure it out. We also know that the Earth is not round. It's elliptical. Also, the debate goes that, is the center of the Earth actually a solid core, molten core? Well, here is the truth of that. No one knows definitively. We don't have instruments that can go down that far. Everything has been a guess. But what's not a guess is that we know that the surface, the mantle, is real, and it has impact. Our planet is not, again, this perfectly shaped spherical globe. If you were to remove the water from our planet, you would see that our planet is, well, rather odd looking. And we can tell as well that, well, we've apparently gotten our butts kicked a few times because we've definitely had something run into us, hit us, or we hit something, however you would like to phrase it. What we do know is this, that our planet is expanding out. Is this a result of a slower rotation? Would that cause the anomalies that we have been seeing, particularly in the mid-Atlantic area? Is this the anomalies that we're seeing at the equator of our magnetopause? Seems like there is something. When you begin to take continental drift into consideration and you go through the millions, hundreds of millions of years, our planet, it's never stationary. It's not even stationary now. Continental drift is this, that. If they're drifting in one way, the planet is only so big. Eventually, you're going to hit something else. We're seeing that now, particularly with the India and the Indian plate. Our planet moves all the time. Great stresses are on our planet. And when we begin to talk about the slowing, the rotation, whether it be advanced or decreased, has tremendous impact on the surfaces. Scientists have been able to pretty well tell that apparently our planet is expanding. Why? It's very difficult to put this all together. And when you begin to think about the strata layer to our atmosphere, this has huge impacts. Remember, jet stream, rivers of air. Folks, it's all connected. Most have no idea of what our atmosphere is composed of. But again, the rotation affects it all the way up to the thermosphere, where the space station is at. Now, as you begin to descend into the layers of our atmosphere, you get additional pressures. This is what we call barometric pressure. When you begin to alter the river of air, even by the slightest, you begin to have this backup effect. Now, our planet's big, and it takes it a while before these impacts begin to hit us. But hitting us, they will. The inevitability is that as the planet changes and as we begin to enter in a period of what seems to be a much more active period, particularly on the continents, we're in for a little bit of a rough go. Our planet shows this already. Go to any good map and you can see exactly what the strata looks like. You can see the topography, even underneath the oceans. And always remember this, when you see the bottom of the ocean, remember, think about the trillions to quadrillion amount of tonnage that pressure puts down on our planet. And as our planet spins, there has to be an equilibrium. And when that equilibrium begins to be out of balance, that's when we begin to get into trouble, big trouble. It's no different. You cause a disruption to an orientation of a spin, you're going to have problems because it's just not our Earth that spins. Remember, our solar system is spinning, our galaxy is spinning, the universe itself is spinning. You take an equation of where you add or decrease, it has tremendous impact. So we know that in many cases, this actually begins to do what we call a sloshing effect. Now you imagine all the oceans beginning to have this resonant effect. It begins to put cracks in the wall. The Earth is a very stable, but yet very sensitive organism. And when one begins to change, it impacts the whole organism. Now, here's the odd thing, though, is that we're noticing this throughout the whole solar system. Every planet is being impacted, some more than others, but it seems like the effect is getting more intensified. Now, could it be that there is something that we have not discovered lurking just right outside our perceptible perception of view? Is there, in fact, something else that is getting closer to us and having a solar wide effect? Could be good science behind this. What we do know is this: it's impacting our planet. The continents are drifting, and when continents begin to move, folks, so do we. The earth is changing. There's no doubt about it. The hypothesis is that could there be an earth within the earth? And is it within the earth that actually has more of an effect on the outside? So what they're saying is that if in fact there is potentially another body within the body of this planet and it's slowing down, would it have a natural drag effect upon what we would call the topography of our planet? And what's up with Jupiter? Acting very strange. In the last 5 years, this planet is really beginning to act strange. Could it be that, in fact, that we just do not understand yet the full dynamics of Jupiter? Could Jupiter be the reason? Jupiter itself is being transformed as I speak. A magnetic reversal is in the process of happening right now. All the evidence shows it. All the data continues to validate it. And when you begin to understand how much our planet is susceptible to magnetic fields of other objects, large or small, you begin to understand what is taking place. And you can begin to understand why there's certain regions of our planet that are impacted greater than others. And whether the Earth is a molten core, a hollow core, whatever it is, it's being impacted as well. When we talk about a magnetic pole reversal, we're in the midst of it. But it seems as well that the magnetic geonorth, and south is drifting. Our planet is shifting. We're seeing this by the evidence. Now, this is one that you can go and look at. This is a model of what our Earth's magnetic pause looks like. Our Earth sends off magnetic signatures. And this is pretty much a normal view. Planet, you can see the red lines are the closed inner magnetic fields. But we began to notice something. A couple of years, it began to show up. Now it's showing up more and more frequent. We don't know what it is. What we can determine by what we see in the models, there's something out there. Now, I can assure you, folks, this is not what our interplanetary magnetic line should look like. Oh, no, 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 no. Something definitely is, let's say, messing with the recipe. And you can see the time date stamps on this. Something has been impacting our planet. Is this the result of the Earth slowing down? Is this what we're seeing? Is this an offset that would cause that? Not sure. But this we do know, something is going on. And 2018 looks to be a very active year for us. So as you sit down to have dinner, get up to get breakfast, have lunch, meet your family, friends, remember this, folks, our planet has slowed. Stay tuned for more details.